Lesson 11 in Module 2 is on the interior angles of a triangle, so the inside. So remember, we've been kind of focusing on a bunch of different types of angles around parallel lines, okay? And we're still going to be working with those, but now we're going to throw in what we know about triangles. So let's start with what we know about triangles. We know that the sum of the three interior angles. Now again, interior is going to be on the outside, exterior is going to be on the outside. Interior, inside, exterior, outside. So the sum, we add them all up, of the three interior angles in any triangle always equals 180 degrees. Okay? So it says use what you know about parallel lines cut by a transversal to help you prove this fact about the angle sum of a triangle to be true. Okay, so just stick with me. I want you to start getting more comfortable with the angles we've been working with, vertical, same side, interior, alternate exterior angles, alternate interior angles, corresponding, supplementary, all of those, probably missed some. Put it all together. Okay, so it says line A is parallel to line B. So this line is parallel to this line. And we want to prove that the sum of the interior angles, so in this case, angle 2, 35, and 62, in triangle CDE, this one right here, is 180 degrees. Okay, so fact. Angle 1. We got to figure out what angle 1 is. And what we're going to do is we're going to use what we know about parallel lines. Okay? Honestly, a lot of times, you guys, it's helpful to kind of extend the transversals. Okay? Because when we do that, we can see things, right? So if I were, I don't know if this will work. Okay. Let's say I just like cover this up here, right? Nope, it's not going to work. Sorry. I was hoping to cover it up, but pretend that you're only looking right here, okay? So we have this parallel line, this transversal. Angle 1 right here, its corresponding angle is going to be down here. Nothing there. But if you look at parallel lines, transversal, notice that angle 1 and 62 are on opposite sides of it. Alternate interior, inside the parallel lines, angles. And we know that alternate interior angles are congruent. So I'm going to say that angle 1 must be 62 degrees, fact. And the reason is, well, angle 1 and angle CDE, that's the 62 degree one, are alternate, spell it right, interior angles. We know alternate interior angles are congruent, okay? So now we can look at angle 3, okay? So in angle 3, if I extend this, trying here, transversal, right? Notice too that angle 3, if we look at these two parallel lines, okay, kind of ignoring this over here, 3 and 35 are on opposite sides of the transversal. So they're going to be alternate interior angles too. So angle 3 right here has to be 35. And again, that's because angle 3 and angle, sorry, these are angle symbols here, CED, okay, same letters, but in a different order, okay, and that's important because we follow the order to know what angle it is, are alternate interior angles. Okay, so now here's what we know. We know that angle 1 here is 62 degrees. We know angle 3 here is 35 degrees, okay? So what do we know about angle 1, 2, and 3? They are a straight line, right? Oops, picked the wrong tool, but that's all right, it'll work. Okay, they're a straight line right here, and straight lines have to add to 180 degrees. So I'm going to say that right here. Angle 1, angle 2, and angle 3 must add to 180 degrees because they form a straight line. Hopefully you can read that. Because they form a straight line. Okay, so we can figure that out, right? If I add 62 plus 35, that's 97. If I go 180 minus 97, that would be 83. 17 minus 9 is 83. So the sum of interior angles in a triangle is 180 degrees because I'm going to type this one out. Oops. By proving that angle 2 measures 180 degrees, we can check the total sum of the angles in a triangle. Okay? And when I do that, we can say that 60, oh, I came up here, right? We came up here that angle 2 here is 83. 62 plus 83 plus 35. If you were to grab a calculator and add those all together, it would equal 180 degrees. Okay? All right. So this is a big idea in geometry, taking things that we know and being able to prove other things. Okay, so let's quickly do this next one. It says that line C is parallel to line D. Lines E and line F are transversals. Fact. Angle 1, 2, and 3. Look at these right here. What do they form? They form a straight line, right? Oops, sorry. So a straight line means 180 degrees. Okay? The three angles form a straight line. That's the word form. See what happens when I rush. Okay. So angle 2, okay, has to be congruent get rid of this one here real quick. Okay, angle 2 and angle 4 look at alternate interior again, right? So we're going to say that angle 2 equals angle 4. Okay, angle 2 and angle 4 are alternate interior angles. All right, and then angle 1 and angle 5. All right, so check this out here. If I draw this line back in, do you see how angle 1 is above and to the left of the transversal? Angle 5 is above and to the left of the transversal. So angle 1 and angle 5 are equal. Why? Angle 1, ooh, that did not look good. Try again. Angle 1 and angle 5 are corresponding. We know corresponding angles are congruent. If I spell it right. They're still congruent even if I don't spell it right. Okay, so we know that 1, 2, and 3 are 180 degrees, but angle 2 and angle 4 are the same thing. So this equals angle 2, and angle 1 and angle 5 are the same thing. So do you see how, again, we just basically have angle 1, 2, and 3 is 180 degrees? Okay, so we'll say if angle 1 plus angle 2 plus angle 3 equals 180, we can substitute. And I'll just say we can substitute and get, instead of angle 1 here, we're going to say angle 5 plus angle 2 is angle 4. And we want angle 3, and that's going to equal 180 degrees. Okay? So we know that the three angles from both of these proofs, we know that the three angles inside of a triangle equal 180 degrees. It's already been proven. We know that. But you can see how it's all going to kind of relate together, our angles around parallel lines and our interior angles in a triangle.